Hello and welcome to this episode of the AI Show. Oh my goodness, I have had a morning. Let me tell y'all. By the way, where's everybody coming from today? If you're looking at, so I had a doctor's appointment this morning. Like, you know, the kind you go to after you're 40, where the dude is like, all right, this is gonna be super uncomfortable for both of us, but we got to do it. Look to your left and cough. And I was in such a hurry. You know, sometimes you see me sipping my drink. I put a shot of, and this isn't it, they don't pay me for this. I put a shot of Mio in there, energy, to spike things up. And I squirted it so hard that it got in my eye. And so if my eye looks weird, it's not because I'm ill or anything. It's because I've got an extra caffeinated eye. This one. I might as well look like this. Hello, welcome to the episode. All right. I'm going to share my screen. Let's do our thing. Here we go. Screen number 3. Boop. Today, we have got some actual guests. Oh, I know. LinkedIn users, got to be careful with those water enhancers, especially when it's in the eye. All right. Today, we have the winners of the OpenCV AI Competition. I feel like I need to say it with emphasis. Cortic Tigers. Yeah, it feels better that way. I think every time we say that, we have to do the Cortic Tigers. And then also, Satya Mallick is here from OpenCV. So if you have any questions for him, he was super gracious. Number 2, we were really bad last week at getting our stuff done. This week, last week, I was like, we're gonna make inference work. We're gonna make inference work. Make inference work. By hook or by crook. Don't forget, we also have the Cortic Tigers. If I had a band name, I think I would be the Cortic Tigers. I would probably play the triangle. And then 3, I thought we would do a little open question thing. And this is throughout the entire show. Just we'll do something a little different. If you have any questions. That's not different. I always do that. Psych. All right. So let's see where people are coming from here. All right. Here we go. Welcome, Ivana. LinkedIn user. Hello. Welcome. I have a yo from Kenrel. I just got a new setup too, so now my screen right here, I have to squint with my extra caffeinated eye. If I twitch, y'all know what it's about. Ivana is here. Hello, my friend. So good to see you. Janiscu, number 7, all the way from Twitchosphere. Irving, hello. Good morning. The Microsoft developer is here. Welcome to that. Welcome to this show. We have someone from India. Gotta be careful with those water enhancers. Yeah. I don't know. Now I need to go see a doctor again. Did I tell y'all I went to see the doctor this morning? I know. Look. My guests are just sitting in there and they're like, "What? Who is this guy?" See this eye? Does it look weird? Hold on. Does this eye look weird? don't think it looks weird. My wife says it doesn't look weird. She's looking at me too. Let's see. Hello, Beldathis. Seth in chat. Yeah, we should totally do that. But yeah, these are the things we're going to be doing. I'm looking for more comments here. What do we got? Hello, Sharafuddin. Hopefully I'm saying that right. Welcome, everybody. All right, so I think that was a very exciting morning. Like I said, I've been running around. Now my eyeball's twitching. So let's get started. Let me remove my desktop here. And let's bring on our guests here. Add to stream here. Hello. And then
Hello.
Hello. And then Satya, let's get you on, buddy. How you doing, my friends?
Doing very good.
Great.
Hi, Seth.
So for everyone watching, we kind of like meet before and like have a sense. So they had no idea that the show was going to be like this, and so they're sitting there thinking, "What have we gotten into?" How you guys doing this morning?
We're doing really well. Thank you.
Oh, fantastic! All right, and Satya's like, "Who is this guy?"
No, I'm just glad that your doctor's visit went well.
Turn and cough. Like, doctor, you need to take me on a date if you're going to do this. Okay? Like, dinner at least. All right. Sorry.
I have a few jokes running in my mind, but, this is a respectable show, so I'll refrain.
It's only respectable during the part where we're respectable. Like, we know how I was telling these gentlemen, that, there's a part where like we get serious and then we record it and then and then there's like the before and the after where y'all can ask whatever questions you want. And so they know this is not the serious part, Satya. So, okay. All right. Just a couple of things. Just look straight ahead when we're talking. Yeah, if you run out of things to say, just stop talking. I'll say stuff. Let me bring up. And by the way, for those that don't know, we have a doc too. We even like make a doc. That's how cool we are. We because I don't want if you come on the show, I don't want guests to be like I'm not going to ask like a crazy question like what's the secret of life, and then they're like no. We talk about what I'm going to ask beforehand because I'm nice. We should bring someone on and do like a gotcha interview, like Brenda or Vanessa. Or Peggy, who also does stuff on the show. All right. Do you have any questions for me, my friends? All right. So now is the serious part. Serious, but not super serious. And I'm going to have the questions. If people have questions, I'm going to get this up. There's more competitions, by the way, Sharafuddin, so you have not missed it. Satya is going to tell you about a new one or some cool stuff at the end. So make sure you stay tuned for that. All right. Let's do this. All right, here we go. Serious time. And by the way, if you don't say stuff like, "Hey, can I say that again?" Because then, or can we edit that part out? Because if you say that, then I have to. One day I'm just going to leave it like, "Hey, can we edit this part out?" Oh yeah, sure. I'm not going to do that to y'all because y'all are awesome. All right, you ready? Okay, serious time. You're not going to want to miss this episode of the AI Show where we talk to the 2021 OpenCV AI Competition champions, the Cortic Tigers. Make sure you tune in. Hello and welcome to this episode of the AI Show where we're talking to the 2021 OpenCV AI Competition Grand Prize winner, the Cortic Tigers, as well as Satya Mallick. Why don't you all introduce yourself? We'll start with you, Satya.
I'm Satya Mallick. I'm the CEO of OpenCV.org. But the highlight of this show is Cortic Tigers. I'll let them introduce themselves.
Let's do it.
Thank you, Satya. My name is Ye, and I'm the CEO of Cortic Technology, and I'm the team leader of the Cortic Tigers.
Hi, my name is Michael. I'm the CTO of Cortic Technology, and I'm also one of the team members of Cortic Tigers.
Fantastic. So let's start with you, Satya. Can you tell us a little bit about what the OpenCV competition was?
So OpenCV AI Competition 2021 was the biggest spatial AI competition in the world, and it was based on this device called OAK-D, OpenCV AI Kit with Depth. And this can do neural inference. It can run neural networks on the device and do depth estimation in real time. And this was sponsored by Microsoft and Intel. We had about $400,000 in prize money, including the devices and the cash prize. And we divided the whole world into 6 regions because we thought that, regional problems are different than global problems. Every region has its own problem. It's not fair to for these competitions to be completely, together. So we had regional prizes as well as one global grand prize. And it was fascinating. I mean, the various kinds of problems people solved with this. And the participation was also awesome. There were like 1,400 submissions for the first phase. And out of those, we selected 250 teams for the second phase. And every team member of those 250 teams, they received OpenCV AI Kit with Depth. And with that, they built awesome, projects. And the final number of projects we got was about 127.
Wow.
And out of those, they were awesome projects. I mean, really, Cortic Tigers was great. The second prize winner is for neonatal care, using the camera looking at babies to monitor their heart and their well-being. And similarly, the third prize winner was somebody with a wheelchair, autonomous wheelchair, things like that. And the submissions, they just blew our mind away, right? It was so awesome. Yeah.
And you were saying, so that's.
Well, that was pretty much what I wanted to say. And, again, thanks to our sponsors, Microsoft and Intel, for helping us do this.
That's really cool. So a ton of submissions. Let's go to you, Yi and Michael. What was it that you built that nabbed the winning prize?
Well, thanks for having us here today, Seth. We built an open source software project called the Cortic Edge Platform, or CEP for short. It's actually a software package that helps students and hobbyists learn and experiment with AI with OAK-D and OAK-D Lite cameras. My teammate Michael here will give a brief overview of what CEP is.
Mm-hmm. Yeah, so the goal of CEP is to allow both the beginners and advanced programmers to start doing rapid AI prototyping. So for beginners with no or need to programming experience, they can start by using the visual programming interface provided in the software. We actually built this interface based on the Microsoft Makecode project.
Oh.
So we extended the project by adding computer vision, speech recognition, speech generation, natural language processing, robotic control, and smart home control into it. So the beginners can start building AI projects right away with these functions. And they can also quickly develop a quick understanding of how AI works by simply drag and drop programming blocks in a workspace. So as they learn more about AI and programming, they may actually want more flexibilities and power to continue building their projects. We also offer a way to convert those visual programs into Python code so that they can edit them in the IDEs such as VS Code, or they can export them into Jupyter Notebook so that they can do exploratory programming. So this way, they have a progressive learning path by using our software. In addition, we also provided an advanced Python API so that they can do distributed AI computation. The syntax of our API is actually very simple. So they can make use of multiple AI devices, such as the OAK-D or OAK-D Lite, to do very complex workflows. And actually, we brought a video today to show some of the use cases of our software.
All right, let me put that up right now.
Mm-hmm.
Hi, my name is Yan.
My name is Michael.
My name is Jen.
We are Team Cortic Tigers. We want to democratize AI for everyone, and we want to do it with the OAK-D. We believe AI democratization starts with people. We want AI to be accessible and affordable to everybody. This is why the OAK-D is such a perfect fit for our project. We are developing software to support the OAK-D to enable people to learn and build using this incredible technology. anyone can get started easily. It takes only a few minutes to write an AI program that runs on the OAK-D using our visual programming interface. You can even use it to build your own robot. Here is our Lego robot, Charlie. You can teach Charlie to say hello and interact with you.
Hello, Michael.
Follow my face.
Ask Charlie to count reps for you when you're exercising. Or even get him to control your smart home. But what if you want to control more devices and need more computing power? Our advanced Python API will take care of that for you. You can easily distribute AI computation to many devices on the network and render the combined result. The OAK-D, together with our software tools, will allow anyone to use AI in any way they want. Whether you want to learn about AI, build a project to help someone, or maybe just have some fun, we've got you covered.
Well, that was super cool. I have 100 questions. So is it, 100, I'm exaggerating, but can I ask a couple of questions to you too?
Of course.
Yeah.
The first is, did you actually use the make code to implement, tell me about the make code bit, because that part is super impressive to me.
So we started with Mako. We thought that it's a very cool visual programming language and it's very extendable. So we just kept on asking custom AI blocks into Mako and hosted the Mako project into our Raspberry Pi. So everything is hosted on the web server on the little $35 Raspberry Pi computer, and you can access and programming everything through your web browser. So you don't need to install anything. It's just very convenient for us.
That's really cool. The second question is the OAK-D camera. did the models run on that camera, or did they run on the Raspberry Pi, or they're in Charlie? Tell me a little bit more about that architecture.
Perfect question. So all of the deep learning models, they actually run on the camera. So it really frees up the host processing power for us to run some of the other business logics. For example, some of the voice recognition and natural language processing that's run on the Raspberry Pi computer. But all the vision deep learning is run on device on the camera. It's awesome.
Interesting. And so when you're moving those blocks around, you're basically getting the information like where's your face, in the picture, and that's being transmitted over, and then you're doing the actual make code stuff with it. Am I getting this right?
You're absolutely right. Yes.
That's cool. And so tell me about Charlie. Now, is Charlie, because I saw Charlie was like counting push-ups and stuff, which Charlie would never do for me. Like I did one sit-up this morning when my alarm went off, right? Sometimes I do too. But tell me about Charlie itself. Is Charlie like a prototype for like an in-home assistant, or is it more of like we want to show you what's possible kind of thing?
Yeah, I guess Michael will take this question.
Yeah, sure. So Charlie is, we have an actual Charlie here.
Oh, hi, Charlie.
Yeah, so it's actually a Lego robot inventor kit. We modify it so that we add a Raspberry Pi 4 in here. So you add as a host, and it runs the CEP software inside. And then we have the Lite that's acting as his eyes, so that he can see stuff and also have the depth sensing. So what we can do with it is that with the interface you just saw, we can actually program it to do a lot of intelligent things. In fact, we have been posting videos of how Charlie works, or how we program Charlie on our Twitter and LinkedIn. So if you follow them, you can see a lot of interesting and fun cases of it.
I see. So it's more of like you're just trying to show the possibility. Now, is there like a GitHub link where people can go and take a look at this code?
Yeah, absolutely. So you can go to GitHub, our CEP GitHub repository, and you can just clone and follow 2-3 simple instructions to get it installed on your Raspberry Pi and experience everything that you saw on the video for yourself. That's
really cool. All right, I'm going to bring you back to the stage, Satya. This is really cool. Are you doing any more things like this?
Oh, we are doing a ton. I mean, it started in 2020 when we did OpenCV Spatial AI Competition. That's when it started. It was a much smaller competition. But the winner of that competition, they built a backpack for blind assistants. So people could wear this backpack and, it would assist them in navigating, walkthroughs and things like that. And because of that success, we did OpenCV AI Competition 2021. And hopefully in the future, we will keep doing these competitions as well. But we are also doing, we reach out to the community for help. When we did OpenCV AI Kit with Depth, we actually reached out to the community for assistance in building this device. We did a Kickstarter campaign and raised $1.35 million with the help of 6,500 backers, and it was the biggest Kickstarter campaign of all time for a smart camera. And since then, we have, based on the feedback we received from our users, we came up with a new version. It is called OpenCV Lite. It is a lighter version. It is, its weight is less than 3 AA batteries, and if you look at it, it can fit right behind my fingers, right? Wow. And it's just as powerful as OpenCV, the same processor. The cameras, the depth camera has a slightly lower resolution and things like that. But this is a camera for the masses, right? It's selling for $79 on our Kickstarter campaign, which you can go to opencv.org/Kickstarter. And this is a 4K camera which can run neural network on it, right? For $79. It's a depth camera where the depth estimation is done at 200 frames a second, for $79, right? And it's so cute. So yeah, I would encourage people to check it out and back it. It's also a really good gift for kids, because with Cortic, we are going to collaborate and bring it for kids, right? We'll create material for kids. My 11-year-old is very excited about this as well. So, wow. Our delivery is right around December. perfect Christmas gift. I've ordered a pack of 10 for all my friends' kids.
I know I'm gonna get, like, if my kid's gonna make robots that can see and do AI stuff, I know I'm pretty excited about that. Well, thank you so much for spending some time with us, everybody. We've been learning all about the 2021 OpenCV AI Competition winners, their project. It's been really cool. Thank you for being with us. Thank you so much for watching, and hopefully we'll see you next time. Take care, everybody. All right, that was so good, you guys. Let's see what questions.
Cool.
Let's see what questions we have here. Someone Beldathus. Thank you. Hold on, I gotta introduce him properly. Beldathus. He likes it. Or they like it. I don't know. I don't want to ascribe gender. I don't even know. I haven't met them yet. Let's see. Cool. All source code is open source. Is the link available? The link they gave me is this one. Is this the link where people can go and take a look at the technology?
Absolutely.
Fantastic. Yeah, go look at that. I honestly, for me, the thing that I like the most is the cleverness of thinking about using the make code to start to prototype this stuff. You know what I'm saying? Because we're all programmer types in our heads. Like, that's what we're thinking in our heads. We're like, the make code picture is in our heads when we're doing for loops, etc.
Mhm.
You know, these pictures get more. But being able to prototype that way, I think, is absolutely genius. Another from Alander Pereira dos Santos is saying, awesome project, fantastic. And then we're having an amazing here. Coming in from Periscope. So, anything else you'd like to add before you take off?
We actually encourage more seasoned developers to try our advanced Python API. So it's actually meant to do distributed AI computation across multiple different devices. And hopefully, if somebody wants to upgrade their smart home or anything, they can just put these devices all over the house and write one simple program to activate everything and get them to work together. So
all I need for my smart home to do is remind my kid to put his laundry away.
You can probably do that.
Charlie's going to live in my house. Satya, anything else you'd like to add, my friend?
Well, I just want to thank our partners also, Laxanas, who is the hardware partner. They designed the hardware, so big shout out to them, and they have been, great partners with OpenCV, and of course Microsoft Azure and Intel for their tremendous support. And thank you for having us here.
Fantastic. All right, my friends, we will see you later. Thanks for being with us. Take care.
Thank you so much.
Thank you.
Bye.
Well, that was awesome. Even with my caffeinated eye, it's this one. I can't even tell. For those just joining, I had my annual checkup at the doctor this morning, and I was just running, to get things done. And as I was making my drink, sometimes you see me sip this drink. The thing squirted in my eye, and I was like, ah! My poor wife. I was like, no, I gotta go do this show real quick. I'm gonna have to buy her flowers. I already did. Okay. Let's see. Here's some other questions. Can I use this in C# code? I don't know. You should go look. Again, there's their GitHub page, github.com/Cortic Technology /CEP. I should do like a side gig of like voiceover things, All right, here we are. It's time to get to work here. Let me move all this stuff. Where did we leave off? This here is too small. Where did we leave off? I'm trying to remember. Oh, yes. I was having a hard time doing the Onyx runtime. So what I'm going to do, I wonder if this will work. Let me look at my scoring file here. So for those wondering, let me just start up the thing so you can see what it is that we're doing. Roshambo.web. I'm building a rock paper scissors game. Yeah. It was an Onyx runtime. I might just have to have one of their people come on and be like, Seth, you're using early technology. We will handhold you. But because, oh my goodness. So the question is, what's happening here? I'll tell you. We are building a web project. Let me load it up here. Let me go full screen so you can see it. That's the sound I make whenever I always forget. We're using Yarn. So Yarn Dev. Yarn Dev. Boop. Yarn Dev. What we're doing is we're building a rock, paper, scissors program where or a website where you can actually go and be like rock, and then it will play against you. So we spent some time building the AI. We decided that the model that was the smallest that had acceptable loss was like a shuffle net or something. But you can see the AI is built right here. This is our trainer where we train it. This is the model that we're using. We're using ShuffleNet as a base layer. Base layer here. Right, that's what we're doing. So let's run it here. Let me open this up here. Microsoft Edge. Get it to the right screen, and then it's a localhost 3000. Localhost 3000. I'm already using one camera, but I have more than one. It's gonna break because I didn't hook up the back end. Remember, we were getting this weird like offset error because we're trying to do inference in the oops. We were trying to do inference in the website, but we kept getting this thing. And it turns out that I asked Cassie, who you know Cassie. I asked her to come on to help out, but she couldn't. She had something. She said she had to wash her hair. I don't know. She said there's offsets and you have to think about all that carefully, and I'm like, So I was like, I don't want to do that. And so like the model works. It's just like it's such a pain in the rear to do it here. Look, I mean, you can see. Remember the code that we had? We were trying to do the inference, and so we decided at the last minute. Let's get it to work on the back end. So the question here, how long does it take make a website? Well, a crappy one takes like 2 minutes. A good one probably takes a lot longer. So, J-Star. Hello, my friend. It is Friday. Welcome. Welcome. So good to see you. So what I decided is, as I was thinking about this, I was thinking maybe we'll just make it work in the back end to start. You know, because we could do like something cool, like a 3, 2, 1. You can't even see me. I'm like doing things, and it was like I can't see you. So we could do like a 3, 2, 1, and then send the thing back, and then have the back end do that. So that's what I'm going to do. But we have some options. I'm thinking Node would be lightweight. But we would have to figure out how to send this back. And one of the things we did that I did not like is when we posted this image to the back end. Let me go to the pages here. We sent like the array. But I wonder if it would be better to get the there's a way to do like a data.image. I was wondering if it'd be better to do it that way, because then we could do some tests. I don't know. So let's do it. Let's get to work. All right, here we go. Here we go. Here we go. Okay, so I need to fire up the entire end thing, right? So let's do this. Let's F5 on the node backend for Azure Functions. Yep. This is right. And then we had to let's do this. Then we had to do like this, the static web app thing. Suwa. No, here. Suwa. Oops. No. Suwa. Oh, jeez. Suwa. Start. Suwa. Start. HTTP. Localhost 3000 API HTTP localhost. What we got? 7071. And what this will do is this will make it so that we can go to 4280 instead. And all of the calls, there you go. All of the calls will go into our API. Okay. Now we're cooking with gas. So now if I do this, we'll be able to, I think, set frame. Do I even call set frame? Video set. No. Let's do this. Set frame. On frame set. And so what's going to happen is now we're not predicting here in the client side anymore. We don't need this. We don't need you. Goodbye. We don't need you. Goodbye. There we go. Happy Saturday, everybody. It's Saturday already in India. Wonderful. By the way, I've only been to India once. I went to Bengaluru and I went to Mumbai. Lovely places. The food is absolutely glorious. Now I'm hungry. I didn't eat breakfast, so all I want is some butter chicken. Great. Thanks for that. All right, so let's go over here to this app. This is loaded. When I hit submit, we should hit a breakpoint right about... Oh, we didn't set the breakpoint. So let's go up to our API. We should hit a breakpoint around here. One would hope. Ooh, let's fix this. Submit. Boom! Okay. So we were able to load the picture. This has the images. Something's wrong with this, though. 307,200. Let's do a little calculator here. Calculator to figure out how many pixels how many numbers we should have. So if we go to the thing here, 340 by 240 times 3. 340. Oops. 340 by 240 times 3. We have too many. We have too many pixels. 307,000. Calculator's telling us 244. Let's see something. 340 by 240 by 4. Oh, wait, no. 320 by 240 times 4. Oops. So looks like we got an alpha channel sneaking in there, and we got to take it out. I remember we copied this code from somewhere. Oh, wait a minute. F10. What happened? Did he get mad? What happened? Okay. I gotta find this repository here. By the way, here's the Kickstarter that we're talking about. I think it was. Let me find it. GitHub.com. Onyx samples. Onyx. Here it is. JS node index.js. This isn't helpful. There was another website. What was it? Here we go. I think this is it. No. No. Inference session. No, there was one that had like the ND array here. This whole ND array thing. Where was it? Okay, let me do a quick history search here. Okay, where is that? Onyx runtime. I think this is it. Yeah, this is it. This is the Onyx web demo, and in the components source, was it utils? Run model. Here we go. No, that's not it. Main. No. Components. Models. Let's look at SqueezeNet. I wonder what it's calling. Here we go. So it gets the image data. Cool. It processed. This is where we got it from. This looks like the right thing. So it's sending back a canvas rendering context 2D. What we did is we pulled the image data out because we were just sending this thing. Let's take a look here. Yeah, we're just sending the data frame. So set frame, let's see here. Yes, we're getting the image data. Just like they're doing over here. Oops. Just like they're doing over here. All right, get image data. We're sending it to the 320 by 240, which is what we want. They get the height, width, and that from the image data. Wait, what does this send back? Image data. Okay. So we send the image data back up the stack here. And what we get the clamped array. Maybe we should send back the whole thing. Let's send back the whole thing. I mean, might as well. Send back height, width, and image data. That way it doesn't have to do that much processing. Height, width, image data. So data, we'll say data with height. Data width height. Data width height. Where are you? It wouldn't let me. Okay, so let's do this. Okay. Cool. We got this. Oh, that's not how I wanted to do it. So we'll say data is going to be the frame dot data. Oh. Data, comma. Width is going to be frame dot width. Jeez. Width. And then the height. This is so embarrassing. Has anyone else spot the mistake I made? Frame dot height. Oops. Boop, 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 boop. That was. Did you see that misspelling? It's ugly. All right, back to this. So we'll send this whole frame data thing back, and let's see if that causes an issue over here. Because this will no longer work. This won't work anymore. Because it's going to be data. And this is going to be rec.data.width. And then .data. Oh, oops. Rec.data.height. Okay. Oh, body. Oof. Okay. This looks nice. I think we need to restart this this thing because what is this? So let's restart it. Okay, F5 again. Doop. For the back end. And back to this happy accident over here. Okay. We'll clear you out. Okay. So now we should be sending things back correctly in the body. We'll see if it likes it, you know. I don't know if it'll like it. Okay. It's like I'm not on camera, but I am, you know, because I'm right here on a different camera. Clarkio rated. Thank you, everybody, for coming. Welcome. Clarkio is the bee's knees. Everything I know about streaming, I learned from him. Yay! And like you're looking at me like on the crappy camera too. I'm gonna go good camera. Good camera. Crappy camera. Good camera. Crappy camera. Good camera. Crappy camera. Okay. So yeah, what we're doing for those that are just showing up, I am literally building an AI right now that when we hit submit, it knows I'm doing rock, paper, scissors. We already built the AI part. As people that have been showing up every week know, the AI part was like the easiest part. The JavaScript, for me, hardest part. So yeah. We did do lots of runs on the AI part. When it comes to AI, we got the runs. Thank you. Thank you. Thank you. Thank you. Thank you. Yeah. So basically, we're gonna be like rock, paper, scissors, shoot against the website. So you don't have to use your keyboard because look, the other day, and this is true, everyone has this problem. The other day, and they're over there. I should go get them. The other day, I was like, I feel like, you know how they have those cracked pretzels that have like honey mustard in them, right? It was like I wanted to eat those, but you get chip hands. How do I say this? You get chip hands. You know when you want like something like a chip, but you also want to like type on your mechanical keyboard that you spent more money than you should have on, just for the sound. And you're just like, I got chip hands. Nobody likes chip hands. But what if when you had chip hands, you're like, I want to play rock, paper, scissors right now. But I don't want to use my keyboard because, again, chip hands. That's what we're building. Like we're solving like real problems right now. And we built what? We tried like what? 36 different models. These are all the ones we tried. Oh, you can't see them. You're like, hey, Goober, make it bigger. I will. So you can see we did like a BGG 19, ShuffleNet 11, DenseNet, ShuffleNet, ResNet, MobileNet, whatever. And we tried a bunch of them. We're like, we have a problem with model size, parameter size, and accuracy. And it turns out that, I forgot to click. Turns out that ShuffleNet gave us a good accuracy, small model. And the accuracy was 100% on the validation set, and the loss was like 0.04. There you go. Now, there. Can we see this now? Okay. And so I thought, like, okay, we just tried a whole bunch of machine. Now let's just make it work on the web, and that's where things went south for me. Because I like had to learn React and stuff. Hold on. Every time I said React, I promised. We had to use React and show some code. Hey, this is a family show. Oh, code. Yes. That's what I'm doing. So let's go back to it. The code to actually run the model is aquí está. It's right here. This is the model itself. Let me zoom it. This is it right here. We're using transfer learning. By the way, if this is the first time you're looking at like deep learning and you're like, hey, I thought there would be more. There isn't. For computer vision, there's more stuff, right? You're building like a generative model. They're bigger, but this is where we live, there it is. And you can see there's my loss function, there's my accuracy, there's the training step. I'm using stochastic gradient descent. I try to say that at least once during the show, just because I think if you're a machine learning person, you have to say something mathy. This is stochastic gradient descent. Step size is variable step size. So that's it. And then this is the runner. And running it, like it makes, here's the model. Let me open it in the file explorer so you can see what's in there. There you go. This is what an AI model looks like in the Onyx format. Move it over here. There you go. This is what AI looks like. No, nothing up my sleeve here. This is deep learning. ShuffleNet's a weirdo though. I'm used to ResNets, but basically all AI is doing is learning a bunch of numbers like this. These numbers. This is look. Hey, Here's some AI for you. So that's what's going on there. Oh, we got a model that we think is small. There's 5 megs, you know, and we thought we would try to get it to work in the browser. We ran into some issues with Onyx. And so now we're trying to get it to work in the back end in an Azure function with Node. And this is where we are at. All right, so everybody caught up? Here we go. Let's take a look at the body here. So request. So let's go to debug console here. Rec.body. Boop. We have the width and the height and the data. So rec.body is, oh, we want data. Data is this just ginormous array. Oh, interesting. Interesting that it did this. Oh, because it's a clamped array. Interesting. Okay. Cool. And so we have here a sample that we brought up here. Let me control plus. Boop, boop. Very good. Hopefully that's big enough. This is what we did. We got the image data. We're here. I think we just can copy this. I'm gonna just copy it. Let's make a function. You think my employer would get mad if I copy code? I hope not. Okay. So we want to have a conversion function. So let's make a conversion function in the helpers here. Do we have a helpers? Let's do this. New folder, helpers. Oh, wrong. No, that's right. Helpers. And then we will say new file. AI.ts. And what I'm going to do is I'm going to take these wonderful things. I'll put them over here. And then we'll say, I'm trying to remember how I did this. When I did helpers in Azure Functions. I don't remember. GitHub.com. My website, by the way, now is all in Next.js. Shared global. Oh, look at that. Look how clever I am sometimes. Global. Okay. Export. Should I make a class? I'll make a class. No. Okay. Export interface. Export interface image data. And that would be, what did we decide it was? And this is a uint clamped array. uint8 clamped array. uint8 clamped array. It's data. So data uint8 clamped array. Height is integer. Width is can I just have integer? Is it int? I'm gonna say number. Number. Good. Okay. So now I can have a function that will return the tensor. So export const convert to tensor. And then what we're going to pass in is we're going to pass in an image, which is an image data, right? Right, and this is going to return a tensor. Okay. 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 I feel like we're doing stuff. We're working here. We're working here. But by the way, can everyone see my screen? Are we good? Should I make it bigger? Okay. Okay. Here we go. Okay. And then we can do this. We can do all of this. And we can just return the tensor. We can just do all of this. Dude. I don't need this. I'm going to just say, you know what? I can literally just do this. Can I do that? Yes, I can. Okay. Okay, so in theory, we can do this. And now, for those of you looking at this code and are like, what in the fresh heck is going on here? I think what's happening. Okay. So basically, we're creating a new ND array. What's coming in is the image data has an alpha channel. Remember, we saw that we had too many numbers. So it pulls it, right? It processes the tensor, the ND array. You know, makes a new one, right, with the new height, the width. Then what it does is it's picking. What does this do? Pick. I think what it's doing is it's starting to move all of the bits from the 3 channels. Yeah, 1, 2, 3 channels into the right spot. You know, RGB into the right spot. That's what this is doing. And then finally, what we're doing is we're doing a division of the numbers to normalize these pixels. And the reason why is because when we look at the data, when we train the model, this is what we're doing, right? To normalizing the pixels. So instead of the numbers being between like 0 and 255, which it is for pixels, it's like between 0 and 1, or between -1 and 1. And so this is the mean and the standard deviation that's multiplied and then divided and added and stuff. So let's see if those numbers match up, though. Split right. Yeah, these are like pretty standard. Yeah, 485, 456, 406, 229, 224, 225. Yeah, so this should do what we want. We're going to change the file name to process, though. Okay. So now that we're in the index.ts, I am going to say, we'll leave this here like this. We'll take these out, and I am going to say import process, comma, image data. Wait, do I need to even from dot, I think is it helpers? Let's call it, let's do shared. Let's change this to rename shared. Okay. Shared / process. Convert to tensor. Okay. So what I can do is I can say const t equals process convert to tensor, and what I can do is I can say image data rec.body. Okay. And then we can say session dot run. What is this feeds thing? Well, let's see what the code says over here. Okay, it's get predicted class. No. Constant empty. Where does it? We don't need to do softmax. Pre-process. So that's cool. Where is the actual where's the actual prediction? Export default class, squeeze net extends view, image URLs, blah, model file path, blah, preprocessed, blah, returns the tensor, get predicted class. Where's this called from? Image model UI. Okay. Image model UI. Here we go. Yeah. Let's find the session here. Constructor. This dot await init session. Okay. Session write. Session model loading. On session backend change. On URL select change. Random file change. Process run model. Okay, here run model. Preprocessed data. This not preprocessed. Okay. Tensor output is null. Run model utils. Okay, so we want run model utils. Where does that live? I feel like we're utils. I feel like we're like utils. Okay, I feel like we're in forensic schools here. Okay. Here's a good question. Are there any resources to learn TS that are absolutely essential for someone new to TS but has a job starting soon that uses it? The TypeScript website is super good, by the way. I think it's good. So here's runmodel.ts. Cool. Warm-up model. Run model. Okay. So record string tensor. Feeds, blah, blah, blah. What's the feeds? Okay. All right. I mean, I'll just... Okay. Maybe we mean session. Let's see here. Yeah, they mean session. Okay. Okay. So model file. Oh, I see. I see what's going on. T. Yeah, see? Yeah, okay, cool. And then what we're going to do is we're going to body predictions, and then we will say output data. Let's see what happens. I mean, you know what I'm saying? Let's just see what happens. Okay, so I think we need to F5 again. The front end is still running. The front end is still running. All right, I mean, this is the closest we've ever gotten to something happening. All right. Here we go. Okay, so that was from before. So let's not get our hopes up here. All right, are we running? We good? We good? Let's just set some breakpoints and hope for the very best. Okay. What? Did it not like that? Oh. ND array default is not a function. Okay, let's go to the process bit here. Here, let's do that because this is the part that's going to be the trickiest. So let's try it one more time here. Yeah, it doesn't like that. This is not like an ND array. Oh, okay. Maybe I'm importing these things wrong. Something's not right here. Let's take a look at how this works. ND array, JavaScript. Here we go. ND array. How do we use these? One. Yeah, this is how it says to do it. How do we import them though? npm install. I wonder. Let's go back here. Oh, we're so close. Where is that code? No, there was like a here it is. Let's do MobileNet. How did they import it here? Yeah, they did it like this. Doesn't like that. So NP array. Interesting. All right. All right. Here we go. So this is coming in good. It's just this right here. It doesn't see this as a function. Maybe I didn't pip install. Maybe I didn't add the package. Let me see. What are we using here? There's the Onyx runtime. And the array is right here. Whoa, this is some funky code. That's funny. There's nothing in here. This is the whole thing? All right, let's see what the... What happened to the... Oh, what happened to the watching? What? Huh? What happened to the watching? I don't know. Oh, the code? Here, let me more screen it. Let's just do ND array TypeScript because that feels like... No. No. There we go. Let me do this. Maybe the types just aren't installed here. No. No. Let me add a new. We want to be in the API. Let's add the types here. Maybe it'll help us. Okay. 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 Oh, this is a problem. I've never seen this. Again, this is why JavaScript. I mean, you know, am I right? JavaScript. Let's see what this says. I don't even know what that means. Do I know what that means? Oh, Stack Overflow will tell us. Oh. Oh, well, that was less harder than I thought. tsconfig.json. Compiler options. BS module interop true. All right. I don't know why I have to do this, but okay. All right. Okay, this is also going to be a problem, but let's see what I did here. Let's see if there's types for ND array ops. ND array dash ops. Yes. Okay. No, there's something wrong with this. This is going to still give me a problem. But let's F5 it, see if it works. Oops. Okay. I think we're making some progress here. We may be able to get this to work today. We ready? We ready? We ready? Be ready for me. Okay. Okay. Yes. 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 No. Check 1 2 check. All right. Hopefully y'all can hear me now. Weird. Can y'all hear me? Give me a thumbs up. Why don't I use Google compared to Bing? Okay, good. Man, something happened. It just went. That was weird. I'll have to fix that later. Okay, where did we fail? But we're making progress though. We're making progress. We're making progress. Okay, so it's gonna be here. I think let's run one more time. I think we're doing better. Where's my thing here? All right, here we go. Okay, are we stopped here? Or? Just trying to see if I get out of the function. Where is this happening? Process JS 28. Oh, undefined. Oh my gosh. Oh my gosh. It bit me in the butt. Bit me in the hind parts. Look at this. Look. That's. Oh my goodness. That's what's broken. That's embarrassing. Oh my goodness. Oh my goodness. That is soup's embarrassing. Yellow. All right. Let's close this. Let's go. F5. Yeah, I know. This is spelled wrong because I'm a goofball and I didn't think to go back and fix it. All right, here we go. Submit. Okay. What you got? You good? You good? What you got? Oh, that makes sense. Okay, that makes sense. I know what's going on. We got to find a way. We got to find a way to resize this image to 224 by 224. Close. So close. Oh my goodness. So close. Okay, let's see if we have any of the other examples to do this. Where do they resize it? Do we want to just cheat and make it 224 by 224? is hard to hear. I had like an audio thing happen. I don't know why this thing broke. Recycle the power or something. All right. Okay. Okay. Hold on. I'm gonna do an audio switch here live. Here we go. Ooh, that's way too loud. Oh my goodness. Sorry. Okay, that's better. Holy cow, that was so scary. That was loud. Oh my goodness. Sorry. Okay. Is that better? No, this is better. Okay. Now, okay. Okay, this is better. Oh, that was scary. Okay. I fixed it. Okay, so we need to do 224 by 224. I am tempted, just for kicks and giggles, to do this. It might not work, but let's just kicks and giggles. Kicks and giggles. Kicks and giggles. Let's refresh you. Here we go. Here we go. There we go. All right. It's squished. You see what I'm saying? It's squished. Holy cow, we're getting stuff back. Let's see what we get back. Nans. Oh no. 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 Nans are the worst. Oh no. Let's see what this tensor looks like. Well, that checks out. We got Batman up in here. Na 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 na. Oh my goodness! Something is going on with this tensor here. T. Let's do the thing. Let's go over here. Let's see what's going on here. Let's see what's going on. Everyone's like, oh, so this is what it means to be an AI developer? Yes. Always getting the wrong index. F10. What's in here, though? Do we have... All right, let's just see what's in here. Data. I don't know if this is coming through. because I should see like data. Let's see what's in the data tensor. Data tensor. Am I not doing something right? Something's broken. Something's broken. Okay. Something was broken. It still thinks I'm running here. I'm gonna restart it. That was okay. All right. Okay. Man. Oh. Who knew that AI would be so not intelligent? Oh my goodness. By the way, any questions as I've been going? Any questions? I'm just looking here. What are people saying here? Thumbs up. Yes, you could hear me. Yeah, my vocal processor just went on the fritz. It was like, I was like, nah. I fixed it. You want to know how I fixed it? I turned it off and on again. Okay. So let's start the API again. No. Let's go cd web yarn. I think it's dev. Is it dev? Yeah. And then we'll F5 for this thing. And then we have to do this thing. I guess here's fine. The SWA, static web apps. Good question. Am I using Anaconda? No, I'm using Miniconda. Miniconda. Good question. Miniconda. There we go. I want to see if we're getting, okay, all those breakpoints are out. I want to see if we're getting, no, the tensor we're getting is all nans, not a number, which means something's going on here. Whoa. Why does it think it's there? Let's do that. Cool. There's nothing in there. Let's take a look at data. Of course it's not there. I need to restart it. That's why. All right, here we go. Is it doing it twice? No, we don't want it twice. No, stop it. What am I doing? All right, we're going to do this in 20 minutes. Okay. Okay, I think we're good. Let's try it one more time. Okay. Let's take a look at our little data thing here. Data. Data. So there's definitely stuff in there, right? We definitely got some things in there. Maybe I don't want to look at it. Cancel. Data.height. Well, now I've done it. But when it comes out of this thing, that's when it gets a little ski-wampus, right? Did I just break it again? Oh my gosh, you gotta be kidding me. Let me see here. Task manager. What is it? VS Code is like mad at me. Buttons work. No. Good evening, Andrew. How are you, my friend? It's good to see you. Welcome. What is going on with my setup today? I wonder if the response came back. Yeah, it just won't start. Wow, that was painful. Oh my gosh, there's so many things happening. I need to stop every single one of them. Okay. Okay. Here we go. Okay, I'm only going to push it once. Oh my goodness. Happy Friday to everyone. It's Saturday for some of you all. Any fun weekend plans you got going on? Okay. Okay. Now. Okay. F11. Thank you. F10. 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 Okay. Let's see what's in data. Okay. Why won't it go? Oh! It won't do it. It's like, I don't want to do it. I'm going to just stop being clever. That's it. I know. I don't know what's going on. It's like won't even, like, for some reason. I have to kill it because it doesn't know that it's dead. What the heck? Has anyone had problems like this with Visual Studio Code? To stop being clever. It's true. I have so far not had a clever moment. Look at this. Something is really weird with this. It keeps firing up. Stop. I don't even know what's happening anymore. Like, I'd restart my machine, but then the show would stop. Maybe that's what we need to do. I'm having like some serious Visual Studio Code issues. Let me stop this. Let me start it over. Oh, maybe I need to upgrade. Maybe I need to upgrade to the newest. Let me upgrade to the newest CLI thing. That's not really going to change anything, but I mean, you know. Control C. Okay. Here we go. Okay. So I'm going to start all of this up again. I feel like we're so close, and we kept hitting like really dumb errors. Like the dumb error that we have now is that this tensor, when it gets converted, it gets converted to a bunch of nans. This thing. And then, of course, so when you pass it through the model, it like returns a bunch of nans. The question I have is it the insider's version? No, I'm not that cool. You know what are my problems? Oh, this is so dumb that I'm doing it this way. By the way, thank you for telling me my problems. Okay, so I'm gonna like undo all of the breakpoints. Undo. 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 Okay. Okay. I'm going to stop it. I don't even know how this is even still working. It's not. I'm going to start Visual Studio Code again. I'm going to close all the things that I don't care about right now. Nice. Okay. Okay, so let's go here. Let's start everything up again. cd web ls yarn dev. We'll add another one. No, we'll F5 for our node project or our backend function. And we got 13 minutes. I think if we can figure out what is going on, we're gonna get some numbers out of this stinking model. Okay. So this is in there. We got that. We'll just start at the root here. And then we'll use the static web app thing. There's got to be a smarter way to do with this, what I'm doing right now. I wish there was like one command to run the whole thing. I don't know if there is, though, to be honest with you. Okay. All righty. Here we go. F11. Okay. If I go to the debug console, I should be able to say image. Maybe not. F10. Oh, man, it all stopped again. Oh, no. Hold on. I have a sound effect for this. I should have gone longer. Like full, like Central America, someone just scored a goal. You know, like goal. It just will not. It won't. I don't understand why this is doing this. This is beyond frustrating. Huh. But this should do the right thing, because it's basically here. Let me tell you what it's doing. Basically, we're getting the image uint clamped array. The uint clamped array here. I just can't see it, which is so dumb. Like I could see, maybe. I mean, can I see rec? No. Here, it's right here. These things. Did it go to the? It did go to the next thing. Oh, blessed day. Let's look at the data tensor here. How do you make this go down? Go down. Go down. So there's something in image. So there's definitely something in the image, right? The data tensor is supposed to have stuff in it. Stack frame not found. There we go. There we go. Okay, things are coming out. I just had to wait. What can I do with an ND array? I wonder. View 3D float 32. There's a so that seems right. Huh, that's why. It's not putting this data into the float 32 array. It's the clamped array. Okay, I bet the clamped array is saving space. So let's see. And I got what, 3 minutes? Honestly, I think if I go to my index here, I think I did something to get the data out before. Let me save this line. Yeah, I checked it in, so let's go take a look at it. AI Advocate, Roshambo. Here we go. We're going to do this. It's going to work. It's going to work. No. Pages. Index. Array from. Let's change that. Over here. So we can control Z. Oops. Okay. 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 So let's go back to this. Let's control C on it. Let's rerun it. Okay. Hopefully this is feeling more like we need stuff in the data tensor for it to work. That's why we're getting a bunch of nans. Time for my walk-off music. It's to help me know that I need to, Okay. Here we go. Still? Let me F5 and see what we get out of it. What did I get out of this? What? Why? Dang, what is going on? I'm pretty sure there's something in data. Yes. Data is, can you do type of data? Is it type of? Type of data. Object. Yes. That's helpful. I think there's something about a uint clamped array something's not right here. Bummer. So close. I think there's something wrong with the way I'm passing things back. But you know what? That's what we do. We get closer every day to the right thing. I'm just going to start shutting this down and tell you about next week's show. I don't know what it is, but they're very helpful in giving me, what's going on for the next one. So for the next show, we have Friday, October 1st, Data Science Toolkit, MLOps Accelerator with Azure Databricks. That sounds awesome. It's been a privilege being with all of you. We keep trying to get it work. We keep getting closer and closer and closer and closer. I've never used Node for machine learning, and so I'm learning along with all of y'all. It's been a privilege being with all of you all. If there's anything you need from me, please let me know. I'm super excited for the next show. We're going to get this to work, and once we do, we're all going to have a super good time with it. Thank you so much for being with us. Thanks for coming. I always appreciate you. Drop me a note if you want me to talk about anything or need me to do anything. So until next time, this has been another fantastic episode of the AI Show. We'll see you next time. Take care.